Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AQIL AIMAN and I will be presenting to all of you for question 1. This question is about the rental fee for two locations of a house in a city. They are assumed to be normally distributed with common but unknown standard deviation. Let's move on with the first question. The question asks us to construct a 1 minus alpha 100% confidence interval between two means. Firstly, we have to identify the number of data from the question. We can use the estimation of difference between two means theorem in this case. We know that t is equal to x bar minus y bar minus mu1 minus mu2 over pool standard deviation times with square root of 1 over n1 plus 1 over n2. Then we just have to derive the distribution on both sides, and all of that is equal to 1 minus alpha. As for the simplification answer, we got mu1 minus mu2 is equal to x bar minus y bar plus minus t alpha over 2 n1 plus n2 minus 2 times with pool standard deviation times with square root of 1 over n1 plus 1 over n2. As for question A2, we have to find the 95% confidence interval between two means. Firstly, we need to know the value for each unknown to be substituted into the distribution. Then, just substitute all of it into this distribution, and the final answer for the difference between two means is negative 162.1117 and 132.1117. For this question, we need to make a conclusion of the rental fees at the two locations. Is it equal or not? Since 0 is in between the interval, thus it does not differ significantly. Therefore, the rental fee at two locations are equal. For question B1, it has been given that the sample size of y bar is in the range between mu minus beta and mu plus beta, and it has a probability of 0.982. So what is n? Since y bar is a normal distribution with unknown mean, and variance is 8 beta square, we can just substitute its value into the distribution, but we need to expand it first, then simplify its distribution. Then, we got the probability of z is bigger than square root 8 over n, which is equal to 0.009. Based on the z-score table, find its value and you will get the square root n over 8 is equal to 2.3656. Lastly, the value of n is approximately equal to 45. For question B2, it asks us to find a 90% confidence interval for mu. It has given a summation of yi is equal to 100 and beta is equal to 5. From previous question, we obtained n is equal to 45. Firstly, find the value of alpha, 1 minus alpha and alpha over 2. So we get 0.09, 0.91 and 0.455 respectively. We also have to find the value of y bar and standard deviations. After that, just substitute into the distribution. Lastly, mu has a range of negative 1.2478 and 5.6878.
Assalamualaikum. Today I'm going to present question 2. Okay, for question 2, we have to substitute y distribution into the momentum function, and we extend x bar and will be summation of xi over n, and then we have to solve n. Then we have to expand summation of xi, and it will be this. Okay, now transfer it to exponential. Now we have to solve it until it will be back again to momentum function, which is we can solve 3 theta over 3 theta. Okay, next we have to compare the chi-squared and we have to find the value of v, which is v is 2n, and we will get the answer, which is y is chi-squared 2n. This is answer for question 2a. For question 2b, we have to do 100 confidence interval for theta. Okay, for this question, we have to find theta and we have to use chi-squared distribution. And okay, for this, we have to use y distribution that we have in A, and then transfer to n x bar to the left and right side. So we will get 1 over 3 theta, and then we have to put 3 theta in above, and the last answer we will get this. For question C, to find 99% confidence interval for theta, we have to find alpha first. Okay, so this for this step, we have to find 1 minus alpha, which is 0.99, and then the alpha will be 0.01. Okay, to find the value, we have to use back the formula that we construct above and substitute the alpha into the formula, and then we will get chi-square of 0.05, and this you have to find it into the table of chi-squared, and we will get this value. And then the last answer will be 4.2348 and 49.4743. That's all from me. Thank you.